आवाज आ रहा है ना?
हाँ सर।
सर्दी हो गया क्या? सर्दी बुखार?
हाँ हाँ।
बुखार की सर्दी?
सर्दी।
सर्दी तो खेल रही। फ्रिज में से कुछ खा पी ली क्या?
खाया पिया नहीं नहीं। पता नहीं क्या हुआ है, इधर हर एक दो हफ्ता जा रहा है, कुछ ना कुछ होते जा रहा है। कुछ खाने पीने की जरूरत नहीं पड़ रही। एक्चुअली ये वाला तो अभी हुआ क्योंकि भाई को हुआ था।
हाँ, ठीक है चल। 4 तो बज गया, चालू कर देते हैं फिर। हाँ।
हाँ
पोटेंशियोमीटर। पोटेंशियोमीटर तो बता दिया था थोड़ा सा। फिर से उसका एक
हाँ
बार रिकैप करा देता हूँ, फिर आगे बढ़ते हैं। तो आज हम लोग पढ़ लेंगे बेसिकली अपना पोटेंशियोमीटर, ब्रिज, थोड़ा सा पावर और एनर्जी देख लेंगे,
हम्म।
हीटिंग इफेक्ट देख लेंगे,
हाँ
और छुट्टी।
हाँ।
पोटेंशियोमीटर में अच्छा एक और फॉर्मूला बता दूंगा बॉक्स का, हालांकि वो कभी पूछेगा नहीं आप, फिर भी बता दूंगा। ओके देख, तो पोटेंशियोमीटर पे लास्ट क्लास में डिस्कशन कर रहे थे। पोटेंशियोमीटर पे आने से पहले मैं थोड़ा अच्छा ये बता रहा था कि मैं थोड़ा थ्योरी बताऊंगा, राइट?
हम्म।
थोड़ा सा थ्योरी बता देता हूँ।
हाँ
पोटेंशियोमीटर, अच्छा मेरा मुंह नहीं दिखा रहा क्या? दिख रहा है अभी?
हाँ।
मुंह दिखने से क्या है, बहुत ठंडा रहता है। पता है वो क्या कर दो। पोटेंशियोमीटर।
हम्म।
तो पोटेंशियोमीटर का यूज हम क्यों लेते हैं? टू मेजर ईएमएफ ऑफ अ बैटरी। ठीक है।
हम्म।
या उसका अननोन रेजिस्टेंस नापने के लिए भी, नॉन इंटरनल रेजिस्टेंस नापने के लिए भी इसका यूज करते हैं। तो इसका एडवांटेज ओवर अ वोल्ट मीटर है। एडवांटेज ओवर अ वोल्ट मीटर, एक्चुअली इसका वोल्ट मीटर के ऊपर एक एडवांटेज है। क्या
हाँ
एडवांटेज है? एडवांटेज ये है कि वोल्ट मीटर भी सही सही नाप सकता है। सपोज एक बैटरी है, मैं समझा दे रहा हूँ, बस उतना लिखा नहीं था वो लिखना। मान लो एक बैटरी है, ठीक है।
हाँ।
ऐसे ही बस है बैटरी, करंट करंट कुछ फ्लो नहीं कर रहा, कहीं सर्किट में लगा ही नहीं इसको।
हाँ हाँ।
ऐसे करके बस अपना, ऐसा करके एक बैटरी लगा दी। अब अगर इस बैटरी को हम लेकर के एक वोल्ट मीटर के अक्रॉस लगा दें, तो बैटरी में से करंट फ्लो कर जाएगा, राइट?
हाँ।
कर जाएगा पक्का।
हम्म।
और ये तो बैटरी के अंदर का बात है।
हम्म।
बैटरी के अंदर का रेजिस्टेंस थोड़ी उखाड़ सकते हैं, बेटा इसको अलग कर लो, खाली ईएमएफ नाप लेंगे वोल्ट मीटर से। तो बैटरी के अंदर का बात है, तो
हाँ
चेंज नहीं कर सकते। इसीलिए क्या हो जाता है कि ये जो वोल्ट मीटर जो नापेगा, वो ईएमएफ नापेगा कि ई
हाँ।
माइनस आई आर नापेगा?
हाँ ई माइनस आई आर नापेगा।
हाँ, ये बेसिकली माइनस आई आर नापेगा, मतलब कि ये पोटेंशियल डिफरेंस नापेगा, राइट?
हम्म।
क्लियर है? और
हाँ
इसको बोलते हैं टर्मिनल वोल्टेज।
हाँ।
दिस इज ऑल्सो कॉल्ड टर्मिनल, मतलब बैटरी का टर्मिनल मतलब बैटरी का एंड्स। टर्मिनल वोल्टेज मतलब बैटरी का एंड्स, मतलब उसमें
हाँ।
वो क्या बोलते हैं उसको, रेजिस्टेंस है, दैट इज ऑल्सो टेकन इनटू अकाउंट। वो टर्मिनल वोल्टेज नापता है। तो हमको क्या चाहिए था? तो ईएमएफ चाहिए था, राइट?
हाँ
तो थोड़ा सा कम नाप देता है हमारा, तो हमारे लिए बहुत दुख का बात है।
हाँ।
इसलिए हम पोटेंशियोमीटर का यूज है। पोटेंशियोमीटर में करंट फ्लो करता भी है तो भी वो एक्यूरेटली नापता है, नल पॉइंट मतलब नल डिफ्लेक्शन मेथड के यूज से।
अच्छा।
ये पहला इसका एडवांटेज है। पहला नहीं, ओनली एडवांटेज, और कोई एडवांटेज नहीं। घाटा भी है, घाटा ये है कि पोटेंशियोमीटर बहुत बड़का होता है।
अच्छा।
तो आप जब लैब में एक्सपेरिमेंट करते हो सर्किट में पोटेंशियल डिफरेंस नापने के लिए, आप
हाँ।
पोटेंशियोमीटर लेके उतना बड़ा apparatus लेके घुसा के नहीं नापते हो। तब आप
नहीं,
चुपचाप
गैल्वेनोमीटर मतलब वोल्टमीटर तो
पोटेंशियोमीटर
काफी
लेके नाप
छोटा
लेते
होता है।
हो। बिल्कुल, तो आप वोल्ट मीटर लेके ही नाप लेते हो। तो ये
हाँ
मैंने पहला एडवांटेज समझाया आपको कि अगर आप अननोन रेजिस्टेंस नाप रहे हो तो भी गलती हो जाएगा। दूसरा,
हाँ
अगर आप वोल्टमीटर वैसे भी सर्किट में लगाते हो तो भी गलत रीडिंग देगा थोड़ा सा। यहाँ अगर हम वोल्टमीटर लगाते भी हैं किसी सर्किट में, ऐसा करके
हाँ
बैटरी है, उसका इंटरनल रेजिस्टेंस है कुछ
हाँ
आर, इंटरनल रेजिस्टेंस है, ईएमएफ भी है और ये कैपिटल आर है, तो वैसे भी ये गलत रीडिंग देगा थोड़ा सा, ज्यादा नहीं। क्यों? क्योंकि मान लो इधर से करंट आ रहा है आई।
हाँ
हमने सीखा था वोल्टमीटर में क्या होता है ऊपर में,
रेजिस्टेंस
गैल्वेनो
ज्यादा होता है।
हाँ गैल्वेनोमीटर और शंट, मतलब सीरीज में लगे होते हैं।
हाँ
बहुत हाई शंट होता है, बताया था ना।
हाँ हाँ
और मैं ये भी बताया था यूजुअली शंट मतलब पैरेलल में लगता है। यूजुअली शंट का जो मतलब होता है वो
हाँ
होता
हाँ
है कनेक्टेड इन पैरेलल। अगर आपको
हाँ
कहीं पर ये वर्ड यूज हो कि रेजिस्टेंस इज शंटेड विथ 10 ओम,
हाँ
रेजिस्टेंस इज शंटेड विथ 10 ओम, मतलब 10 ओम है और एक रेजिस्टेंस को शंट कर दिया इस तरह से, ये लॉजिकल मतलब है यूजुअल।
हाँ हाँ।
तो उस केस में भी हम शंट बोल देते हैं, क्योंकि और कोई वर्ड है नहीं हमारे पास वैसे भी,
अच्छा।
बोल देते हैं चुपचाप शंट ही बोल देते हैं उसको। हालांकि ऑफिशियली दिस इज नॉट कॉल्ड शंट अगर वहां लगाएंगे, ठीक है।
हाँ
तो इस केस में क्या होता है, हमको एक्चुअली जो वोल्टमीटर का रीडिंग होना था
हाँ
वो आईआर देना था इसको,
हाँ
पर वो दे क्या रहा है। अगर सपोज ऊपर कुछ है, करंट चला गया अपना आईजी,
हाँ।
एक्चुअल में जो मेजर्ड रीडिंग है वो क्या हो जाता है, आई माइनस आई जी
आई
इंटू आर।
माइनस आई जी इंटू आर।
तो एरर कितना का आ गया, एरर परसेंटेज अगर निकालेंगे हम,
हाँ
तो अगर आप ध्यान से देखोगे तो एरर आएगा आपका आई जी इंटू आर का एरर आ रहा है।
हाँ
एक्चुअल था आई आर
हाँ
मल्टीप्लाइड बाई 100, मतलब इतना नेगेटिव
हाँ
एरर है, मतलब इतना कम नाप रहा है।
हाँ हाँ।
समझ में आया? ये माइनस बोल दो आप,
हम्म।
माइनस आई जी आर, ठीक बोल रहा हूँ।
हाँ
मेजर्ड माइनस एक्चुअल, यस मेजर्ड माइनस एक्चुअल बाई एक्चुअल इंटू 100, यही होता है एरर।
हाँ हाँ
तो ये नेगेटिव एरर आ रहा है इतना, आई जी इंटू आई बाई 100 का ऐसा एरर आता है। तो इसलिए वोल्टमीटर में थोड़ा सा हमेशा एरर, आई मीन इन अ वोल्टमीटर यूजुअली सम एरर कम्स, but in the
हाँ
case of potentiometer it is free from errors. That is an advantage, but natural disadvantage of potentiometer is that it is very bulky to carry from one place to another. Okay,
हम्म।
so that is the thing. Now there is another thing that we
तो
have to
इतना
understand.
छोटा सा एरर तो एमीमीटर में भी आता होगा।
Ammeter में बिल्कुल आता है, because ammeter also has its own resistance, so current
हाँ हाँ
it alters little bit certainly.
हाँ हाँ।
Therefore, it
What is
can be
this written? Potentiometer to measure
potentio,
EMF.
yeah, potentiometer.
Okay.
Okay, so first advantage we discussed. Now another point in potentiometer is sensitivity of potentiometer. So this we will discuss after discussing potentiometer. Otherwise, anyhow you will not be able to understand it properly.
हाँ
Sensitivity एक बार मेरे को याद दिला देना. We'll discuss sensitivity. Okay.
हाँ
Okay. So now let us focus on the arrangement. I mean, what you call.
One second, I'll just note that down.
What you can do, you don't need to note that. It is theory portion. What I'm telling you now is more important.
Okay.
Making of a potentiometer. Now you see how a potentiometer looks like. We had discussed in the last class also. Again, I'm just repeating it because today we need to complete this portion. So yes, one thing we had told that just we discussed, potentiometer is used to measure EMF of unknown battery.
ईएमएफ बैटरी।
EMF of a battery. It can
हाँ
also be used to measure internal
इंटरनल
resistance
रेजिस्टेंस।
of a battery. Okay.
हाँ
These are the two purposes for which we use a potentiometer. Now say for example, here is a battery. The first case I'm not assuming.
EMF is electromotive force, right?
Huh. So this is a battery. This is a resistance wire we had discussed. This is a resistance wire, and from here, so there is a battery. This is its internal resistance. There is a galvanometer, and this is the galvanometer being put on the. I mean, this is called a jockey. This arrow thing which you are seeing, it's called a jockey, which can be shifted over the resistance wire. This yellow portion is the resistance wire. This is known EMF called E. This is unknown EMF called E. Let the internal resistance be R. The length of this wire be L. And its resistance be, say, capital R. Okay, I'm just telling you a theory, and I'll take more examples also to explain the things more clearly. Okay. So now let us focus on this. The setup is clear to everyone.
हाँ
Setup is pretty simple. ऊपर में there is one known battery E. Below there is unknown battery E whose EMF we need to find out. We need to find out the value of this E in terms of this E which is known to us, L known to us, R known to us. These terms we need to find the value of. So what we do, we keep on sliding this jockey left and right so long we don't find a specific position, and of course this is calibrated, this is a scale. This yellow
हाँ
portion is not just it's calibrated also. मतलब you can measure the reading, this many meters, this many centimeters, it's calibrated. So you keep on sliding the jockey till the time there is no current flow through the galvanometer. Okay, keep sliding till the time the current flow through the galvanometer becomes 0. What does this mean? This means that the flow of current through this circuit becomes 0. Correct, no? Because galvanometer there is no current.
हाँ
This means the current in the bottom circuit becomes 0. This means all the current is flowing where? Only in the above
upper
circuit.
circuit.
Yes. So now what current will flow in the upper circuit? Since the bottom circuit has no role to play, we can just imagine the upper circuit. I am showing you very slowly, part by part, then you'll understand everything. If the bottom circuit has no current, then it means there is no role also that it has to play in current. So only role played will be by the upper circuit, right? This is the only circuit that will play some importance. It has some importance. The bad EMF is E. Now its resistance was R. Length is L. So what is the current? Current is going to be how much?
E by R.
Yes, simple. It is E by R. Okay. Okay. Also, let us say the potential here be 0 volt. Can we say? Because there is a lower terminal, we can say potential is here 0. Here potential will be E, right? Okay. Now, if you say that this is the distance x which we can measure because it is a calibrated scale. The yellow one is not just a resistance wire, it is a calibrated proper scale. And the x we can see. So say for example, we have got here x, where when I keep the jockey, the current flow in the bottom circuit is 0. Okay. So now look at the bottom circuit. If you look at the bottom circuit, what is the potential difference between point x and y? If no current is flowing, I'm drawing the bottom circuit separately.
So no potential difference.
Potential difference will be there. See, I've just drawn, I've separated the lower circuit, okay?
हाँ
Let this point be x, let this point be y. So if there is no current flowing, what is the potential difference across x and y? I is 0, then
E.
only potential difference will be E. Yes.
E.
Everybody understood this much? Or in the bottom branch, no current is flowing, right? So when you travel from here, x, you are coming, you jump. It will be minus E drop. Then again going, you reach till y. All right?
हाँ
This is clear to everyone now?
Yes, sir.
So in the bottom branch, only potential drop will be of E. And potential is dropping when we are going from x to y because Vx minus E is y. So which is at a higher potential?
minus E. हाँ X.
X is at a higher potential, right? Because when traveling from there, E ka drop hua, there is a drop of E. Then we are reaching y. Okay. So now you see, similar thing should happen here also because x and y is common. So this is only x and this is only y, right? I have just separated these two circuits like this, but they are the same points. This x is same as this and this y is same as this. So X is at a higher potential. This is logical also. If you see the upper circuit, the current is flowing, coming like this and going in this fashion. So naturally, this yellow portion is a resistor. So when we go in the direction of current, there is drop in the resistor. So it is accepted that Vx will be greater than Vy. Okay, from the upper circuit also, from the lower circuit also. This was just clear to everyone?
हाँ
Okay.
Yes.
Now I can find what is Vxy using the upper circuit separately. Because Vxy will be I into R of xy.
हाँ
And I calculated how much? E by R. And what is Rxy? What is the resistance of xy? So see, I'll tell you.
L by R into
For entire L, the resistance is R.
हाँ R
For-
by L
for-
into L.
Yes. So for 1 meter, the resistance will be R by L, right?
हाँ
So for X meter, the resistance will be Rx by L. Clear to everyone?
हाँ
Yes, sir.
Yeah.
So E by कहाँ था रे? It is E by R into resistance of xy is resistance per unit length into the length that we need. So we are getting Ex by L. This is method 1. If you need Vxy, there is a method 2 also, which I generally use and which is used worldwide. This method also I use at times. So whatever I'm comfortable with, we can use. Method 1. Method 2. Potential drop across length L is E. You are seeing? Here it was E.
हाँ
Here it became 0. So potential drop over a length of L is how much?
E
E. Potential drop over the length L is E. So over a length of X will be how much? E by L into
E
X.
by L into X.
Unitary method.
हाँ
And that is what we need. So
हाँ
Vxy directly we can get E by X into L, which is same as this. And this is the EMF of the unknown battery only, because Vxy was E.
हाँ
Okay, got it?
हाँ
Yeah.
This is how we measure the EMF of an unknown battery. So I'm giving you 2 to 3 questions. All of you quickly solve it. There is nothing in theory. Everything is in numerical only there. Too fast. Question number 1 done.
Yes, sir.
Question number 2.
Yes, sir, चल रहा है.
Question number 1 I am showing. See, of course, here it should have been mentioned that galvanometer there is null deflection, means there is no current flowing in the bottom circuit. Okay, this is already assumed. It will be mentioned in the question. I had not mentioned. So now the current is only flowing in the upper branch. How much current will flow in the upper branch? The 28 volt is mentioned, and what is the total resistance? 4 plus 10 ohm. They are in series. So 14 ohm. The current that is going to flow in the upper branch is 2 ampere. All of you agree this much?
Yes,
Okay.
sir.
So this current is going to come like this, and it is going to come like this, and so on. Now I assume this potential to be how much? 0 volt. Then this will be how much? 28 minus 8, 20 volts. Yes or no? See, you start coming from here, you come, and then when you cross this, it will be minus 8 IR, the drop, then minus 8 plus 28. So it becomes 20 volt here. Now we need to find potential difference between this much, that is the EMF of the battery. So 20 volt drop we have observed in a length of how much? 10 meter. This is called potential gradient. Potential gradient, let us say denoted by, let us not denote it by anything. There is a special term used for this. It's called potential gradient, PG. Don't write like this, but I'm just showing PG. It is delta V by the length, that is 20 by 10. That is 2 volt per meter. Means in 1 meter, 2 volt drop is going to be there. Logical, right? 2 volt drop per meter. Therefore, in 10 meter, 20 volt drops, and we get 0 volt. So in 4 meter, how much will drop? So in 4 meter, the
Okay.
drop is 8 volts. So therefore, we have got the potential difference across this thing, and that is 8 volts. That is the answer. Everybody got this?
Yeah.
To the next one. Next one question is copied.
Yeah.
ठीक है, then I'm going to the next one. साक्षी पहला समझ में आ गया ना?
हाँ सर, पहला हो गया था.
Okay, good. Second question is done.
Yes, sir.
Okay. Second question, what is the answer?
I'm getting 2.5 meters.
पूरा 5 मीटर आ रहा है मेरा.
अच्छा. Okay, let us check. See, what is the current that will flow? 2 amperes, right?
हाँ.
Yeah.
In this direction, 2 ampere current is flowing. Okay. So let us take this as 0 volts. Then this is going to be 30 minus 10, 20 volts. इसमें drop हो जाएगा 10 volts and this increases by 30, right? So overall 20 volts. All of you are doing by this way or not? Or doing using some other
Yeah, I
method?
did this.
यही.
I mean,
Yes,
use this
sir.
potential gradient method only. This is 20. Okay. Now, if you carefully observe, then focus here, please. When I'm going from left to right, potential is increasing or decreasing? Using the above circuit.
Decreasing.
Using above circuit, potential is decreasing. And if you look at the bottom circuit, when you go from
Potential
left to right,
increasing.
potential increasing or decreasing?
Increasing.
It's increasing, right?
हाँ.
So you'll never get a null point only in this case.
Ah.
Means answer was given find x. I have not mentioned that you have got null deflection. You have to find x. So you'll never get x.
ये मैंने देखा था पर मैंने सोचा कि उसका पोलैरिटी मैटर नहीं करता होगा.
करेगा ना मैटर तो लॉजिकल है ना सब. वो हड़बड़ाना नहीं आंसर लाने के लिए. पोलैरिटी मैटर तो करेगा ना. नीचे वाले सर्किट से you are able to understand, no?
Yeah.
So you'll never get a point like that. I don't know if you solve it, what you will get. अच्छा solve कर लेंगे तो हो सकता है
If
कुछ आ
we
जाए.
take it as null deflection, then we get as 2.5.
Okay. But point is that you won't get any deflection here. Got it?
हाँ.
Yeah.
Yes,
So
sir.
take care of the polarities. The battery should have the same polarities like that. Yeah.
हाँ.
What if it was minus 10 volts, like the battery was like inverted?
Minus 10.
Then
The battery is
we couldn't
inverted, then
find-
so you'll get the answer. If the battery is inverted, then it becomes the first question like first one only. Then in that case, if you solve it, so what is the potential gradient? 20 by 5, right? Delta V by
it's
length.
4.
And this delta V by length multiplied by x should be equal to 10. So x should be equal to 10 by 4, that is 2.5. Then you would have got that.
Okay.
I mean, EMF would have been 2.5 volt. But otherwise, it's not. So make sure that take care of the polarities. And आपको ऑप्शन में दिखेगा भी 2.5. बेटा -1 खा के आएंगे आप लोग. देख के करिए. Question number 3, question number 4, question number 3. Question 3 and 4. 3 done.
हाँ,
3 का आंसर
no null deflection.
null deflection नहीं आ रहा है.
Can you show question 3?
I'll show. Question 3. Anybody got any answer or not?
I'm still solving question.
Answer is
10.9 आ रहा है पर वो तो होगा ही नहीं ना.
हाँ, अगर आप सॉल्व करेंगे तो 10 से बड़ा आ जाएगा आंसर. See, let us start solving. So, what is the current in the upward branch? Of course, here's a null deflection, we'll assume. And then find x. So, the total resistance in the upper circuit is how much? 10 ohms. 8
Yeah.
ohms plus 2 ohms is 10 ohms. So, current will flow here 4 ampere. Let us assume this one 0 volts. This one will be how much? 32 volt, I think. Yes, 40 minus 8. This one we have got 32 volt. What is potential gradient? 32 by 10.
हाँ,
Correct?
हाँ,
3.2 volts per meter. And of course, when I am going from here to here, potential is increasing. In the bottom circuit also I am seeing potential is increasing. They have proper polarities.
हाँ.
Now, if you carefully observe, the maximum potential difference. Okay, anyway, let us first calculate. It's 3.2 volts per meter, right?
हाँ.
I have to measure how much? 35 volts.
35.
So,
हाँ.
how much meter is required?
10.9.
3.2 volt means 1 meter. So 35 volts means 1 by 3.2 into 32 meters, right?
Into 35.
Oh, sorry, 35. Correct?
Huh.
That is how much? 35 by 32 means it's greater than 10 actually.
हाँ.
And the wire we are having is of how much?
10 meter.
10 meters. This means there will be actually no null deflection. The circuit is wrong. The circuit is not wrong, circuit is correct. But we are not able to measure 35 volts. Problem is this. We can't get a null deflection for 35 volts. Why is that? See, logically try to see. I'm erasing all these things now. Logically try to see. This entire thing, the entire yellow portion is producing a potential difference of how much? 32 volts. Yes or no?
32 volts. हाँ.
Yeah.
And I am supposed to measure 35 volt. Then how can I measure? My maximum potential terminal voltage that I am creating across this battery, 40 ohm battery, along with this 2 ohm is 32 volt. That is the potential 32 volt I can measure. And I have fitted a battery of 35 volt, which is more than that. Then it is not possible to measure it. Got it?
हाँ.
Yeah.
Yes, sir.
So it's not possible to have a match. So sometimes, so the necessary condition is that they should have same polarity. You have to check the polarity. You also have to ensure that the terminal voltage across the wire, the yellow wire, that should be greater than the EMF of the battery that we are supposed to measure. If it is simply asked, if it is simply written that sufficient criteria that the battery which is connected here should have greater potential than the battery connected here, is it sufficient criteria? No.
No.
40 volt is more than 35 volt, we are seeing. So
Huh.
it is not the potential of that battery which matters. Actually, it is the terminal voltage created here that matters. Got it?
हाँ. हाँ.
If there is no battery here, then this statement is correct. पर इस battery के चलते drop आ जाता है ना, तो terminal potential becomes different than 40 volts.
हाँ.
So that we have to take care of. Okay, everybody understood this question?
हाँ.
Then go to question
हाँ,
number.
sir.
The answer is actually you will not get any null deflection. No null deflection. Mathematically also it's coming greater than 10 means no null deflection, and physically we have to understand that 35 volt is greater than the terminal voltage of 32 volts that we are getting. No
हाँ,
null deflection. Question number 4, solve it.
हो
Can you
गया.
just give a brief statement for what you just said about the terminal voltages?
If terminal voltage is greater, if terminal voltage is less than the EMF of the battery connected, I mean the EMF of the terminal voltage is greater than the EMF of the unknown battery, then there cannot be any null deflection. Question 4 is copied.
Yeah.
हाँ, हो गया.
ठीक है, बाद में गिरी होगा, पहले बेसिक कर ले. ठीक है, क्वेश्चन 5 क्विकली सॉल्व. अरे यार मैं रिकॉर्डिंग नहीं कर रहा है, तुम लोग याद नहीं रहता कि रिकॉर्डिंग कर रहा है. बोलो. अच्छा रिकॉर्डिंग चल रहा है. अच्छा मोको आ गया, तुम लोग रिकॉर्डिंग में आ गए. ठीक चलेगा. I told all of you to remind me that we have to record the lectures, okay? All of you should remind me always.
सर खुद ही भूल जाते हैं, भूलने वाले को क्या रिमाइंड कराए.
और मैं भूल जाता हूँ.
नहीं मतलब मैं भूल जाती हूँ, मैं वही कह रही हूँ, आप भूलने वाले को रिमाइंड कराने कह रहे हैं.
तुम अलार्म लगा लो मोबाइल में क्लास में घुसते ही. ओके, क्वेश्चन 4 डन और नॉट?
हाँ,
कितना है x का वैल्यू?
5 मीटर.
हाँ ठीक. Everybody got? चलो देखो बता रहा हूँ. See, galvanometer will show null deflection, right? So current in the upper branch will be 0. All of you agree? So
Yeah.
all the current is going to flow through here. So what current is going to flow? It is going to flow in this 5 ampere, because resistance is 4 plus 2, 6. 30 by 6 is 5 ampere, okay? So if 5 ampere current is going to flow, what is the terminal voltage I will get? Let's assume here 0 volt. So it's 30 minus 5 to the 10. 30 minus 5 to the 10, that is 20, right? 0 volt, 20 volt. Okay, terminal voltage I have got 20. So what is potential gradient? 2 volt
2
per
volts
meter.
per
2 volts. हाँ,
I need to measure 10 volt. I need 5 meter, simple. Right? 1 meter I'm getting
Yeah.
2 volt. I need 10
हाँ,
volt.
हाँ.
I need 5 meter. So the x is going to be 5. Finished. That is the answer. So potentiometer clear to everyone? How to measure EMF of unknown battery? So now
Yes.
put the heading measuring unknown resistance. Measuring internal resistance of a battery. So every battery has two things. Actually, if you see in the above circuits, I have always drawn the battery with their internal resistance. You see the figures? You see the figure, I have always drawn the battery with their resistances, you see? But that R I have always written, it never came in the picture only. You see here also I draw the resistance, but I never mentioned what it was. You check all the pictures, you have drawn the internal resistances always. But we never bothered about it because
Current is not flowing to the.
Yeah, current is not flowing, so therefore we were never bothered. But how to measure it? We need to measure it, na? We need to measure it for precise calculations of a practical purposes. We need to measure that. वो कैसे नापेंगे? Battery का EMF we have known, but then how to measure the internal resistance also? So there is also a way for that. I'm showing you. Please take a look carefully. Again, I'm using simple way. We are again drawing the setup with our potentiometer. This is called potentiometer wire. Potentiometer wire. It's usually a wire of 10 meter. 10 meter means back and forth your room sometimes, like from here to there, from there to like that. 10 meter is quite long. That is 10 meter wire. That is a normal length of an experimental potentiometer wire. Anyway, then we have here a battery. Here we have a battery. We connect it to a galvanometer to get a null deflection. And there are actually multiple ways to measure the internal resistance of a battery. Let us say this is E, this is E, this is R. So first, to measure the internal resistance of the battery, first you need to measure E. You can measure E, right? That is the step one. First of all, you find this E. So this E is now no more unknown. It's known to us. Okay. Then we need to find out small r. So what we do, we can do there are like multiple ways to do, out of which one simple way I'm showing you. What can be done is, say you simply connect a resistance parallel to this. Simply connect a known resistance parallel to this, okay? All of you are able to understand the setup? There is no hard and fast rule. I'm just telling there are multiple ways. उसमें से एक तरीका I said that connect a known resistance R. Okay. Now, when you connect this and again move the jockey, say for example, at one point of time you get a null deflection. Okay. So when you get the null deflection, as soon as I get a null deflection, what does that mean? It means that current through the galvanometer is 0. Now current through the galvanometer is 0. Please take a note of it carefully. Look carefully here. Current in the upward branch is going to be there, right? Some current will flow here, no problem. And some current also is going to flow through this branch. This branch is independent. Both the branches are going to have their currents, but current in the galvanometer is 0 means no current is coming from here. No current is coming from here and no current is going. You are getting? It means both the circuits are independently acting now. With their individual currents. There is no link between two. You can draw the two circuits individually also. But for the sake of your understanding, I am drawing out. This circuit is one circuit and the bottom circuit is independent now. They are two independent of each other. But what is the link between the two? There is a link between the two, that is these points. The points will have the same potential difference still. Right or wrong? If I call them points as x and y, then points to circuit पे एक ही है ना? So Vxy should be same for both the circuits. Everybody got it?
Yeah.
So for both the circuits,
Yes,
Vxy will be same. So if you focus on the above circuit, then I can find out Vxy, right? We have found so far अब इतना देर से तो यही निकाल रहे थे. So Vxy for the upper circuit is going to be how much? Vxy is going to be potential gradient multiplied by the length of xy. Say it is x. Say this length be x, okay? This is the potential xy. And now what is xy as per the lower circuit? As per the lower circuit, I can find potential xy, how?
I,
So let us say the current
हाँ,
be I, and then I hope आप लोग समझ पा रहे हैं, निकाल पाएंगे हम लोग.
हाँ,
If this is I,
हाँ सर.
then there are two ways. You can directly say either it is IR, potential drop across xy is IR,
हाँ.
that is
E
I
by
is,
R plus R.
either you can say E by R plus R into R, this much, simple. Okay, or you can also say it's E minus IR. So if you solve it, you will get these two same only. Okay, you put the value of I as E by R plus R, you will get the same thing. Is it clear? Theory portion is clear or not?
हाँ, हाँ, हाँ.
हाँ सर,
So
clear.
now look experimentally, both should be equal. It means E by L into X should be equal to E R by R plus R. Clear to everyone?
हाँ.
Clear, sure? Okay. This E is known to us, X. We have eyes. We can see what is X on the board. L is known to us. E we have found using the previous scenario, unknown battery ka EMF. We know how to find, we found out. R is known to us. R is known to us. This R we can calculate.
हाँ.
Clear?
हाँ.
So what is the essential point?
अच्छा सर, हमारा टारगेट बैटरी का ईएमएफ निकालना था या
बैटरी का.
तो बैटरी
I
का
didn't get how you got
कहाँ निकला?
ER by R.
ऐसे पहले क्या पूछ रही है राखी?
मैंने कहा तो बैटरी का कहाँ से निकला? वो तो आर का निकला ना.
इसका क्या निकला रे?
कैप मतलब बैटरी का इंटरनल रेजिस्टेंस का कैसे निकला? मतलब वो तो कैपिटल आर निकला ना.
बैटरी का इंटरनल रेजिस्टेंस इज दिस वन. This
हाँ.
R is a known resistance जो हम लगाएं. This R is known to us. We have fitted it here. These
अच्छा,
parameters are
उस
known.
इक्वेशन से निकल जाएगा. हाँ, 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 समझ आ गया.
From this equation we find out the value of small r.
हाँ, हाँ.
Okay, Zara, yes, what you're telling?
Yeah, I was saying that I didn't get how we got that ER by R plus R.
See now, what is the current in this circuit? Capital R, small r are in series, na?
Yeah,
So what is the current? E by capital R plus small r.
okay.
Yes or no?
Yeah,
Now clear?
yes,
Sure?
yeah.
What else is not clear?
That's it. That part I do want to be
Which one?
confused. That is me. You explained it.
This one.
Yeah,
See, Vxy as per the lower circuit we need to find, right?
yeah,
So now you go from X to Y like this. So only drop comes is of here, IR. When
yeah.
you cross a resistor, there's a drop of IR, right? So you
Yes.
can get Vxy as IR and I wrote as E by R plus R.
Okay.
Not clear?
Yeah.
Now clear? Okay. And using the upper circuit also, if you go by this way, like you can go via any way, you can go via this way also, via this way directly. So in that way, potential difference is, like say we are going from right to left. In that way, potential drop is minus IR because we are going in the direction of current. If you see current, ऐसे करके आएगा. This is the direction of current, right? So minus IR plus C. This is Vxy. I mean, you start from here. VR minus IR plus C equals to VL. Yes or no? This we have learned, right?
Yeah.
So in that way also you can find. So we need to find VLR basically. That is VL minus VR. That is E minus IR again. Same. Okay. We'll solve some
सर
questions.
ई
and it will be-
माइनस स्मॉल आई मतलब आई स्मॉल आर होगा ना.
बिल्कुल बिल्कुल small R होगा. Okay. Clear to everyone?
Yes.
Okay. Then we'll solve some questions and it will be more clear. Don't worry. It's all current electricity. It's not specific to potentiometer. Now the questions are going to be like any random question can be asked on this. I will show you it. Draw the figure quickly. बना दिए. और क्या करेंगे? Let us very this. At 3 meter, I got null deflection. What is this? Acha, this EMF. I'm giving you it. EMF of this battery is known to me. 5 volt. This internal resistance you need to find, and this resistance I'm connecting is of 4 ohms. Find the internal resistance of the battery. Simple question, just follow the logic. The logic is that when there is a null deflection, upper circuit and lower circuit behave independently. That is the logic. Now just use that. You have to tell at what x I will get null deflection. Question 1 done.
हाँ
Question 2.
वो कर रहे हैं.
Question 1 should I explain? साक्षी क्वेश्चन 1 हुआ?
हाँ सर 2 कर रहे हैं।
क्वेश्चन 1, चलो मैं एक बार क्वेश्चन नंबर 1 I'm trying to explain also. See, I have got a null deflection. That is very good news, great news. It means upper circuit and lower circuit behave independent of each other. So in the upper circuit, can I find what is the current? It's 2 ohms plus 8 ohms, 10 ohms, 20 volt. 2 ampere current is going to flow. So 2 ampere here current is flowing like this. Okay. Let us calculate. Here it is 0 volt, 2 ampere into 2. 4 volt ka drop plus 20. 16 volt will be here. Yes? Okay.
Yeah.
हाँ
The
सर
terminal voltage is 16,
sir.
length is 2, so the potential gradient is 2 volt per meter, and it is dropping when I'm moving from left to right. Okay. Now, okay, 3 meter दिया हुआ है, means what is the drop in those 3 meters? 6 volt. That also I can tell, right? So in 3 meter drop is 6 volt. Okay. It means the potential from here to here should be of 6 volt. From P to Q, the potential drop should be 6 volt. Correct? That I'm getting from above. This much is clear, not to everyone?
Yeah.
हाँ सर
Yes, sir.
Check. So now let us okay, from P to Q, let us go not via this way, let us go via this way. It seems more simple. I'll simply get I into R, and it is a drop. See, from P to Q, there I have written there is a drop of 6 volt, mind you. So from P to Q, when I go via the path mentioned in the arrow, there will be a drop only. Okay, make sure the drop and increment should go side by side. So P to Q, there's a drop of IR. What is I? 5 by 4 plus R multiplied by 4. This is the drop across 4, and this should be equal to 6. Yes or no?
Yes, sir.
Clear to everyone?
Yeah.
यस सर
10 equals to 12 plus 3R. R नेगेटिव आ गया? तुम लोग का आंसर आ गया था क्या?
हाँ
12 plus 3R equals to 10. All of you got proper answer? Or
हाँ
you got R negative?
नहीं मुझे तो 1 मिला।
ऐसे 1 मिल गया रे भाई.
5 by 5 R by 4 plus R। वो R तो अननोन नहीं, मैंने तो E minus IR से किया।
तो भी तो वही आना चाहिए.
हाँ 2R is equal to 6। हाँ
So as per the data, we are supposed to get no null deflection here. As per the data. Even if I take E minus IR, while traveling from P to Q, there is a drop of 6 volt, right?
हाँ
So from traveling from P to Q, what is the drop? 5 minus IR. This is the drop.
हाँ this is equal to 6।
Right?
हाँ एक सेकेंड।
किरे
अच्छा हाँ नेगेटिव ही आना चाहिए। हाँ अरे वो मैंने 6 minus 5 किया तो
तुम अरे मत करो अभी.
हाँ
समझ में आ गया?
हाँ
So answer is coming negative means I am taking random data, so therefore it came negative. Okay.
For
So
the
I should
second
give.
one, which formula did you use for this one?
Wait, just 1 second. For the second one means here, this one.
Yeah.
While traveling through the battery, its drop is of, what is the drop? So first drop is of 5 volt, right? Not minus 5. I'm already considering drop, so I'll tell 5 volt is a drop. Therefore, I've taken plus 5 while going straight away from here to here.
Okay.
And then IR is opposite of it. I'm traveling against the direction of current, so I've written minus IR. Got it or not?
Yeah.
So anyway, it's coming out to be negative. So now okay, first write down no null deflection for this case, and I change the value. In place of this 5 volt, I'm giving you 10 volts. All right. Now you'll get a data. Solve it. In place of 5, you can take a 10. In place of this 5 volt, all of you could notice the change in question, right? I've made 10 instead of 5.
अब आ रहा है 16.
अब आ जाएगा. Okay, so now let us solve it back. So see, still, if even if I make it 10, there is going to be no change in the upper circuit, right? Because they were independent.
हाँ.
So for the bottom circuit, the potential drop of 6 should be equal to I is 10 by 4 plus R multiplied by 4. Everybody understood this part?
Yeah.
2
हाँ
3
sir.
ja, 2 2 ja. So I'm getting 12 plus 3R equals to 20. R equals to 8 by 3. Got it?
हाँ हाँ.
समझ में आया नहीं आया?
हाँ समझ आया.
हाँ sir.
क्वेश्चन 2 करिए.
Yes, sir.
सॉल्व क्वेश्चन 2. To solve question number 2, you have 2 minutes. ज़्यादा बोल रही है 1 minute.
हाँ, हो गया.
I hope everybody is copied at least the question. I'll go write the next question. अगला क्वेश्चन पहले बता दे रहा हूँ, मेरे को पता नहीं क्या लिख रहा हूँ. अब परेशान मत होइएगा, आंसर नहीं आएगा तो. हम्म। क्वेश्चन नंबर 2 बता रहा हूँ। हाँ, यू हैव सॉल्व्ड क्वेश्चन नंबर 2 और नॉट?
हाँ
ओके, आई क्विकली सॉल्व इट। सी, अपर सर्किट एंड, अच्छा बोला क्या है, एक्स निकालने बोला है फॉर नल डिफ्लेक्शन। तो मीन्स अपर सर्किट लोअर सर्किट आर डिफरेंट। फिर से भरोसा नहीं, आंसर आएगा कि नहीं? आंसर आया था क्या ठीक ठाक इस बार?
हाँ आया था।
ठीक है, देख लेते हैं। तो व्हाट इज द करंट फ्लोइंग? 8 amperes, right? 32 by 2 plus 6,
हाँ
8. So 8
हाँ हाँ
ampere current is flowing. Let us take the potential here as 0 volt. The potential here will be how much? 32 minus 16.
24.
32 minus 16.
32 माइनस 16 क्यों?
IR ना, 8 एम्पियर करंट है, राइट? सॉरी, 4 एम्पियर
नहीं
करंट।
4 एम्पियर।
सॉरी, करंट will be 4 amperes. Yeah, 4 into 2, 8. So 24 volt, correct. Terminal voltage is 24 volt, fine. So now, considering X, what should be the potential drop? 24 by 10x, yes? And that should be equal
हाँ
to, from the bottom circuit, if we see, what should be the drop? So considering the bottom circuit, what is the current that is flowing? The bottom circuit can be further simplified like this, if you see. Means if we travel from here, it is 7 minus 4, that is 3 volt equivalent. I can draw like this. And 2 plus 1, 3 ohms in series. Equivalent circuit for the bottom one, right?
हाँ
Yes or no?
यस
Yeah.
सर।
So the current flow will be 1 ampere. Okay, very nice. So the current flow is 1 ampere here. So what is the drop across this? 7 minus 2, 5. Drop when I'm going from left to right is how much? There's a drop of 7 and there's an increment of 2. The current is flowing in this fashion, right? Please try to understand. So I'm going in the direction of, against this battery is minus 7 and plus 2, minus 5. So drop is of 5 volt. And when you go from here to here also, drop should be of 5 volt. Means this should be equal to how much? 5. Are you understood or not understood anything?
Yeah, I
हाँ
got
अंडरस्टूड।
So x is equals to 50, but please को हटाओ यार इसको. 12, 5, 25 by 12 is the answer. This much meter. Okay.
सर एक बार आप लास्ट वाला पार्ट बताइए।
कौन सा वाला?
आपने 3 वोल्ट्स और 3 ओम्स ले लिया।
3 वोल्ट और 3 ओम लिया.
हाँ तो
हाँ
यहाँ से आपका करंट आया 1 एम्पियर।
हाँ.
तो उसके बाद आप नल डिफ्लेक्शन किसके लिए निकाले? 2 ओम्स के लिए या 1 ओम्स के लिए?
नल डिफ्लेक्शन तो बेटा यहाँ पे आ रहा है. मतलब यहाँ
हाँ
से इस सर्किट से कोई करंट फ्लो नहीं करेगा. दिस इज द मीनिंग ऑफ नल डिफ्लेक्शन. नीचे सर्किट इंडिपेंडेंट हो गया.
हाँ
तो नीचे सर्किट
तो
करंट व्हेन आई फाउंड,
हाँ
then I just calculated potential difference across say x and y. That's it. It has nothing to do with null deflection.
हाँ तो इसको आप इक्वेट किससे किए? मतलब
ऊपर वाले
5
पोटेंशियल से, ये वाले पोटेंशियल से.
ऊपर वाला पार्ट समझ आया। मतलब मैं कह रही हूँ कि नीचे में आप ई माइनस आई आर में आप आर किसको लिए?
मैं 7 ओम और 2 ओम वाला को यूज करके बोला.
हाँ मैं वही पूछ रही थी। हाँ
हम्म,
ठीक है।
ठीक है.
हाँ
Any other questions?
नो
So I've got x as 25 by 12. Okay. Solve the next question quickly.
पर यहाँ पे अगर मैं पूरा जॉकी को हटाऊँ तो 2 बार नल डिफ्लेक्शन आएगा ना?
पूरा जॉकी को हटाऊं तो 2 बार नल डिफ्लेक्शन आएगा.
जॉकी को हटाओ मतलब पूरा जो लेंथ दिया है 10 मीटर, तो
अच्छा.
उसमें 2 बार नल डिफ्लेक्शन आना चाहिए है ना? एक बार 2 ओम्स के लिए, एक बार 1 ओम्स के लिए।
और ऐसा थोड़ी होता है. नल
मतलब
डिफ्लेक्शन 2 ओम के लिए 1 ओम के लिए नहीं आता है ना. नल डिफ्लेक्शन तो उस पोटेंशियल डिफरेंस एक्स वाई के लिए आता है.
हाँ मतलब जैसे एक बार हमने E माइनस आई आर में 2 को बिठाया, दूसरे बार 1 को भी तो बिठा सकते थे ना।
बेटा वही आंसर आएगा। अरे पगली, एक्स वाई का तो पोटेंशियल डिफरेंस वही रहेगा ना, जो 4 वोल्ट और 1 ओम को भी लेकर करो, पोटेंशियल डिफरेंस एक्स वाई का वही रहेगा ना सर्किट के अक्रॉस।
हाँ
अरे मैडम,
हाँ
4 वोल्ट पकड़ ले, फिर कुछ देख। इफ यू गो बाय द बॉटम वे, इफ यू गो बाय दिस वे, तो व्हाट इज द पोटेंशियल ड्रॉप? माइनस
हाँ हाँ
फोर
हाँ
प्लस हाउ,
-4
व्हाट वाज द
हाँ
करंट फ्लोइंग? हाँ, इसमें भी ड्रॉप ही होगा ना, बिकॉज वी आर
1
गोइंग इन द
हाँ ड्रॉप
डायरेक्शन
ही
ऑफ
होगा,
करंट, तो
हाँ हाँ
स्टिल
हाँ।
5 इज कमिंग, राइट? पोटेंशियल
ठीक है
ड्रॉप
ठीक
थोड़ी
है।
2 पॉइंट के क्रॉस चेंज हो जाएगा, आप अलग अलग
नहीं
तरीके से
नहीं नहीं
कनेक्ट
चेंज
करेगा।
नहीं होगा, हाँ 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 समझ आया।
ओके, थैंक यू फॉर आस्किंग। नेक्स्ट क्वेश्चन, क्वेश्चन नंबर 3। क्वेश्चन नंबर 3
हाँ
सी,
कर रहे हैं।
both the galvanometer G1 G2 showing null deflection. There is unknown EMF E on the top, unknown resistance R, potentiometer wire connected, length L, resistance R1, E1 E2 connected. Look at the polarities of E1 E2 carefully and then solve the question. Look at the question carefully for E1 and E2, polarity देख लीजिएगा E1 E2 का, then start solving. एक अच्छा क्वेश्चन था। हे कृष्णा। All of you solved some questions from electricity, electric current, yes, direct class में you all come and sit and then enjoy the lecture.
नहीं चैप्टर हो जाए फिर सॉल्व करते हैं, मतलब जैसे
अरे
इलेक्ट्रोस्टैट के लिए भी तभी किया था।
एसीबी तो मैं तो होमवर्क देते रहा था एसीबी का।
इलेक्ट्रिसिटी में अब HCV का होमवर्क दिए थे।
अरे in the last class I told you ना, apart from potentiometer you can solve all the questions.
हाँ 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 वो, अरे सर
हाँ सर।
एक्चुअली अभी क्या है KVBY थोड़ा पास आ रहा है, तो उसके लिए बाकी सब्जेक्ट थोड़ा ध्यान ज्यादा दे रहे हैं।
हाँ, ये बोलिए। एंड बाकी लोग
हाँ
I
सर
have
करते हैं
started
एक सी
doing the
क्वेश्चन।
solved example.
solved examples of what?
HC Verma. I have DC Pandey too, but you told HC Verma, so I will doing that.
Hmm. The way I have taught
I
you
was
can
having
solve.
a few doubts in the electric potential questions.
Okay, you can ask.
So I'll send it to you maybe tomorrow or after
Yeah.
class today.
Yes, no problem. Electric potential from where? HCV.
Yeah,
Potential means electrostatics.
yeah.
Okay, no problem. You can ask after the class also if you have, or you can collect all the questions, ask in one shot, your choice. Tomorrow,
Yeah,
like I'll
that's
be
good.
like tomorrow I'll be bit. I may be a bit packed. Tomorrow you
Let
can.
me know when you're free, so I'll just
Huh?
let me know when you're free, so I'll just gather all the questions and send it to you at once.
Tomorrow I can be free after 6 o'clock evening. Tomorrow I may travel to
सर
Kolkata.
आया 4।
4 आ गया, शाबाश।
हाँ
हो सकता है 4 आए, I don't know.
सर पर ये अच्छा क्वेश्चन, पर हाँ मैंने एक एजम्पशन किया कि E1 ग्रेटर देन E2।
बहुत बढ़िया जमसन। Everybody solve question 3 fast. तो चेक करे तेरा कैलकुलेटर मिस्टेक तो नहीं है?
हाँ किया चेक, धीरे धीरे
ओके
ही किया।
ओके, पार्ट 2 भी कर ले। Okay, I'm doing question number 3. Anybody solving or should I tell?
I'm solving.
Solve first. Yeah, 1 more minute. KPY कब है रे?
KVPY 22 को होता नवंबर को है, पर इस बार थोड़ा दो बार पोस्टपोन हो गया।
अच्छा, मतलब 11th में जो होना था अभी 12th में हो रहा है ऐसा?
हाँ हाँ हाँ
वो अच्छा।
नहीं, नवंबर में जब होने को था तो कोई स्टूडेंट ने वो केस किया कि मल्टीलिंगुअल होना चाहिए एग्जाम। तो हाई
मल्टीलिंगुअल?
कोर्ट, हाँ मतलब हिंदी और इंग्लिश में होता है, तो बाकी लैंग्वेज में भी होना चाहिए, तमिल
अरे
वगैरह।
बाप।
तो फिर हाई कोर्ट ने ऑर्डर दे दिया, तो अब रुक गया। फिर जनवरी में होने को था, तब कोविड इतना बढ़ गया कि वो पीछे होते होते 22 में।
Okay, I am solving then question number 3. Okay, see, one thing is clear that when I am going from left to right, there is a potential drop, right?
हाँ
Okay, what is the potential drop for 120 centimeter? What is the potential drop? So let the terminal voltage be V. Okay,
हाँ
and we will have a specific value which we are not mentioning, but let it be V. Means
सर, मैंने वो जब जैसा आप 0 और वो पकड़ के कर रहे थे, मैंने वैसे ही पकड़ के किया।
हाँ, कोई दिक्कत नहीं है. I am just telling a shortcut. I can take this 0, take this V. V value can be specifically found out in terms of E, R and R1.
हाँ हाँ हाँ
But no problem, let us take it V only. If there is a need to find that potential gradient V, will find out. Okay,
हाँ
but we can assume it V safely. Okay, and the value of V certainly
हाँ,
will be
वो
something.
मैटर ही नहीं करेगा।
Let it be V. So for 120 centimeter, I can write V by L, that is the potential gradient, multiplied by 120 centimeter. Let us call it
1.2।
1.2 meter. Yeah. Everybody is understanding or not? This is the potential drop, right?
हाँ
For 120 centimeter for the upper circuit, and for going via this, what is the drop? E1 plus E2 is the drop.
हाँ
So sorry, E1 minus E2 is the drop. हाँ क्या?
हाँ
Are yes or no?
हाँ हाँ हाँ
Everybody understood this?
Yeah.
Okay. So this much is clear. The first equation, and if we for the bottom, what is the potential? V by L into 200 centimeter, right? So
हाँ
200 centimeter drop is V by L into 2, and that should be equal to potential across these 2 points. So dropping across these 2 points. What is that? So drop across this is E1 and drop across this is E2. So E1 plus E2. That is the total drop. Clear?
हाँ
So you simply divide, you'll get it. So you'll get 1.2 by 2 equals to E1 minus E2 by E1 plus E2.
नहीं
Implies,
सर, मैंने इनको ऐड किया, फिर सब्ट्रैक्ट किया, फिर डिवाइड किया।
और भी कर सकते हैं, कोई दिक्कत नहीं है.
इसमें कॉम्पोनेंट डिविडेंड लगाएंगे।
अरे जो भी लगा हमको तो पता नहीं था. इसमें कैसे करेंगे? 12 by 20 is how much? 3 by 5 is equals to. So E1 minus, I need to find E1 by E2. So I'll divide ऊपर and नीचे. हाँ, ऊपर and नीचे I'll divide by E2. So let E1 by E2 be
हाँ,
X.
ऐसे भी
So
कर
here
सकते
I will get X minus 1 by
x
X
plus
plus
1।
1.
हाँ
Okay, everybody understood ना? तो आवाज ही नहीं आ रहा.
हाँ सर, अंडरस्टूड।
तो 2x equals to 8, x equals to 4. पता नहीं 2 बोल रही थी.
नहीं, मैंने 4 ही कहा था।
अच्छा, everybody got like understood how to do it. Since the process is same, there is no change in process.
हाँ, पर ये क्वेश्चन सुंदर है, मतलब डरावना है, पर आंसर अच्छा आता है।
ठीक. और दूसरा point for null deflection of E1. So for E1, what is the null deflection point? Okay, how to find that? Okay, so what will be the deflection for E1, right? So using 1 and 2,
सर ये आ रहा है 0.4 E1 पर E1
तो
तो नोन नहीं है.
कुछ तो आना चाहिए. ओके, E1 एंड E2 का तो रेशियो भी आ गया. Okay, see E1 and E2 ratio we have got, right?
हाँ,
So
आप ये V/L का वैल्यू निकाल सकते हैं.
बट अभी एक मिनट रुक जा. Okay, let us see. So if I add these two equations, what I am getting? V by L into, basically I need V
3.2.
by, means let us say X. So V by L into X is E1. Let us say this much.
हाँ हाँ
So I need to find X, right?
हाँ
All of you agree this much?
हाँ.
Array, let us
हाँ
say at
सर.
X. Let us say at X, I am getting null deflection for E1. So this is going to be the equation, na?
हाँ.
अरे आप लोगों को ज़रा not clear?
Yeah.
Yeah means yeah or no?
It is kind of clear, but I'm a little confused.
See, this much is clear. I'll put only E1 now and galvanometer. Okay?
हाँ अब आ गया.
Figure is clear?
Yeah, figure is clear.
Okay. Now you see. Now whatever the case be, let's say this is 0, this is B. And let us say at X, I'm getting null deflection. So potential gradient is V by L, right?
Yeah.
And at X, I'm getting null deflection. And this is the potential drop, right? V by L into X.
Yeah.
And let this be E1.
Okay.
So in question, it is asked, what is this X? Tell me that proper value. Got it? No question.
Yeah.
So basically, I need to tell the value of E1 L by V. This is X basically.
हाँ.
This much understood or not?
Yeah, understood.
Now I need to find this value. So let us add these two equations above. So if I add what I will get, adding these two, V by L into 3.2 equals to 2E1, right?
आ जाएगा.
चुप रहे बेटा. इतना क्लियर है सबको? हाँ
Yes,
मतलब आप
sir.
बोल सकती है. हाँ हाँ
हाँ
खाली
सर.
हाँ 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 बोल सकती है.
हाँ हाँ मुझे समझ आया.
This is 1.6, okay? So what is E1 L by B? 1.6 meters. I got it. This is the X I needed. अरे भैया.
हाँ
Understood ना?
हाँ हाँ.
Yeah. Yeah, I got it.
Yeah. ठीक है. तो अभी डांस करिए. पोटेंशियोमीटर खत्म हो गया अपना. So potentiometer now infinite questions can be asked. Essentially, you have to understand circuits will be different. You have then it basically like current electricity only. There is nothing more special about it. Potentiometer clear. We learned how to find the EMF of unknown batteries and their internal resistances also. Now put the heading meter bridge. Acha, I told little bit. I'll tell about some theory also. So some theory about potentiometer I have already discussed in the beginning of class. What was that? That potentiometer is a more accurate device in comparison to voltmeter. And another theory about potentiometer is very important. Sensitivity of potentiometer. Write down sensitivity of potentiometer. What is the, I'll go little fast, please copy fast. Sensitivity of potentiometer. So what is the meaning of sensitivity? Sensitivity means two things. First, can measure small potentials. So if there is a potentiometer which can measure small potentials, since it's not potentials, I mean small potential difference or small EMFs, either small potentials or small EMFs, then it is called a sensitive potentiometer. Or it is also called sensitive if for a small change in EMF, pardon my handwriting today, I don't know what has happened. All of you are able to understand my handwriting?
हाँ
Yeah.
sir.
If for a small change in EMF, there is a considerable change in balancing length. Balancing length means the null deflection point. If you say, for example, there is a battery initially of 20 volt, it was giving null deflection at 2 meter. Write it down. These are the two criteria for a sensitive potentiometer. You will call a potentiometer sensitive if it can measure small potential differences, and for a small change in the measurement of EMF, there should be a considerable change or a large change in balancing length. Okay, that is called sensitive potentiometer. Like say, for example, if I have a EMF of 20 volt battery, and for that I was getting 1.5 meter balancing length from the left. Now say, for example, I bring 22 volt battery. The EMF change is how much? 2 volt. But now say, for example, balancing length I'm getting at 4 meter. Sensitive or not? Quite sensitive.
हाँ sensitive.
You increase just 2 volts and your balancing length is increasing by quite a good amount. You're getting?
हाँ.
So it's quite sensitive. So it can, so because this balancing length is quite large, in fact, you can measure up to 20.4, 20.5 volts also you can measure. Because this balancing length is seen, the difference is quite large, right? Means if you go from 1.5 to 2 to 2.5 to 3 to 4, means in between what all things will come? 20.5, 21, 21.5, 22. Means it can measure more what do you say, in details of EMFs also it can measure, because we are getting balancing length is large. The difference of the balancing length is large means in between like 20 to 20 to 22 tak lot of things you can measure in between. So it's called sensitive potentiometer. It can measure a lot of things. Not a lot of things, I mean it can measure potential to more accuracy. Are yes or no?
हाँ yes sir.
Clear to everyone?
हाँ मतलब मैं डेसिमल्स में आराम से मेजर कर सकती हूँ.
Is it clear to everyone when the potentiometer will be called sensitive?
Yes, sir.
Yes, sir.
Okay. Now write down factors for sensitivity. Factors for sensitivity. First, there is only one factor actually. If you logically see, V by L into X is basically EMF of the battery. Correct? Now, this X is the balancing length that I want to be actually large. I don't want it to be very small. Like, please don't say that, sir, take a potentiometer like this. Take a potentiometer wire of length 1 centimeter. Can we make this or not? We can make this, there is no problem.
पर इससे काम करना बहुत मुश्किल है.
If you take 1 centimeter potentiometer wire, then measuring things will become very tough. Means I can practically show you using data also how it becomes tough. Let me show you quickly. Wait. Say this is 60 volt, 10 volt, something R. So what is the potential gradient? 60 by 10 to the power minus 2
हाँ.
into X is equals to 10. Yes or no?
हाँ.
Everybody understood this?
Yeah.
Huh? Clear?
Yes, sir.
Okay. This goes to show what is the balancing length? 1/6 into 10 to the power minus 2 meters. Sorry, this is centimeter actually. But I'm calculating it in meter. Okay, so this will be like this, correct only. Means you understood now. I converted it here only meter. 10 to power minus 2 meter in potential gradient. This is equals to this 10 volt.
हाँ
So we are getting answer in meter. So this is basically 1/6 centimeter. Can you measure 1/6 centimeter using a normal ruler which you will use here?
नहीं, उसके लिए तो फिर वर्नियर मीटर ये सब चाहिए.
1/6 meter. Sorry, what is that? 1/6 centimeter. Huh? So it's very tough to measure it. You're getting no? अरे चमगादड़ लोग. See, to measure
Yes sir, yes sir.
to measure 1/6 centimeter is not so easy. Got it now? And say for example, amazingly, say for example, if now the EMF of the battery is 20, how much? 20. So the answer is going to be how much? This is going to be X, right? If in place of this 10, this would have been 20, the EMF, this would have been the answer, right?
हाँ,
It's 1/3 centimeter. Difference is very large or very small? 1/3 centimeter to 1/6 centimeter, large or small? It's very
छोटा.
small.
हाँ, बहुत ही छोटा.
और पोटेंशियल का डिफरेंस 10 वोल्ट का आ गया. It's a highly dull potentiometer. Because even if you make a slight mistake in calculation of length, you will make big errors in calculating potential of the battery. Not understanding.
हाँ हाँ हाँ.
Everybody understood or not? Or should I show again? अरे भैया. This calculation is
समझ
clear?
आया.
Yeah.
In place of 10, if you write 20, means like if this battery would have been say 20, then this would have been the calculation for X. It's going 1/3.
Yeah.
1/3 and 1/6 are very close. Whereas the potential 10 to 20 volt is quite considerable. It's 10 volt difference. So if you are measuring 1/6 centimeter, now 1/3 and 1/6 are very close to each other. So now we are human beings. Now little bit also, if you go from 1/6 to 1/3, means the reading you will get will be disastrous. Therefore, X should be large. The X should be large, and for that X to be large, V/L should be small.
हाँ
Understood?
हाँ.
So this E is constant. तो battery का EMF. X should be large. So V/L should be small, na? So for sensitive potentiometer, the potential gradient should be less. So write it down. This means for high sensitivity implies the potential gradient should be very less. That's called sensitive potentiometer. Now for potential gradient to be less, two things are there. Either you increase the length. This means again two things. Either you increase the length or what else you can do?
Decrease potential.
Decrease the terminal voltage.
हाँ.
Or you can decrease the terminal voltage somehow. Decrease the terminal voltage, decrease V basically. This is clear to everyone or not?
Yeah.
Yes, sir. Yes, sir.
Not this much. So now say for example, there are two potentiometer wires given to you. You simply calculate V/L and you can tell which is more sensitive potentiometer. If this kind of question comes, I hope you can solve. You just have to calculate V/L, that's all. Check whose V/L is more. जिसका ज्यादा होगा उसका sensitivity कम होगा. ठीक है?
हाँ.
Okay, so I'm not going into numericals of that sensitivities. I hope you understood this section, sensitivity of potentiometer.
Yeah.
We'll go to the next topic, put heading meter bridge. बाप रे बाप. Sitting and teaching is more difficult than standing and teaching.
क्यों?
डांस करते रहते हैं, खड़े खड़े टाइम पास होता है. Human body is meant to move ना. You are biologist, right? Future doctors.
हाँ, पर वो बायोलॉजिस्ट नहीं है.
Okay, meter bridge. Let us focus on meter bridge now. In meter bridge, what we do? There is no bridge. There is a known resistance R. Okay. There is an unknown resistance, say X. So in meter bridge, what happens? There is a ruler like this. And meter bridge means this is fixed 1 meter. It's a potentiometer. I forgot to tell you one thing, that in normal potentiometer, potentiometer wire length is of 10 meter. You can write down. I'm not writing. Potentiometer wire which is there, its usual length is 10 meter.
Yeah, you mentioned this.
As I mentioned it, usually it's of 10 meter. So how 10 meter you will keep? So what they do, they take a cardboard of 1 meter length, and like that they make 10 windings. 1, 2,
सर
3.
मतलब एक पोटेंशियोमीटर
4.
तो पूरा लैब के समान हो जाएगा.
हाँ तो मोड़ देता है ना पगली 10 बार उसको.
ओहो, अच्छा.
That there
हाँ.
are 10 windings. Means 1, 2, 3, 4, 5, like that. And how they keep reading? They take reading like this. So this is one end, and finally you came out from here. There's another end.
हाँ हाँ.
So say for example, I'm drawing it little zoomed away. Okay, say you got the reading here. It's more also. Continue. Say we started the jockey from here. Now take a note. I start the jockey from here, and I got reading here. Say this is 30 centimeter. Everybody is understanding or not?
Yes, sir.
This length is 30 centimeter. So how? So what is the actual reading? 10 meter.
4.3.
Sorry, 1 meter, 2 meter, 3 meter, 4 meter, 4 meter, 30 centimeter, 4.3 meter. Clear? That is how we take the reading actually in a normal potentiometer in a lab. That's how it is taken. Okay. So therefore, you see V by L. L should be large. This is how L is made large. So that potentiometer is sensitive. Okay. I'm rubbing this portion. I hope you understood.
हाँ.
Let us come to meter bridge. So in meter bridge, the length is always 1 meter only. It is fixed. It will not be specified to you in the question because that is a setup only. It's a 1 meter fixed. Okay? So 1 meter guaranteed. And there is a jockey. So here is a point, and here is a jockey. I'm drawing in red. Like in potentiometer, we had a jockey. Jockey means nothing. It's just a wire like this. It is connected here. So say for example, I get L here, at which here's a galvanometer connected in between. So here in galvanometer, current is 0. Okay. Means you're getting the setup or not. Here is a known resistance R.
Wheatstone का ना?
Wheatstone. It's like a Wheatstone bridge. Here X is unknown resistance, and this thing is a resistance wire of 1 meter. It might have some resistance, say R. So it has a resistance of R. All right, and specific resistance of rho. Okay, length is 1. So now I move the jockey on this blue wire, and say I get null deflection from this 0 to 100 centimeter. Here is the mark. So I get, say at X, say at X mark, I get null deflection in the galvanometer. What does that mean? Means no current is flowing through the galvanometer, right? So if no current is flowing through the galvanometer, it means it acts like a Wheatstone bridge. If you carefully see, this is R, this is X, this is rho, length by A, and iska resistance is rho L by A, right? Current through galvanometer is 0. Yes or no? Everyone, you understood this or not?
हाँ हाँ
Yes, sir.
Okay. So I need to find this X. This is unknown resistance which I place it. So how will I find? So R by rho X by A, or let us multiply it. I had told you opposite multiplication should be same. Better multiply it. So this means rho into 100 minus X by A into R should be equal to rho X by A into capital X. देखिए 5 सेकंड और बोलिए समझ में आया कि नहीं? Understood?
हाँ
So rho get cancelled, A get cancelled, A gets cancelled. Therefore, R by X is going to be X by 100 minus X. It will be simply a ratio of lengths. And I know the value of R, I can find the value of it.
सर ये
Principle is
किए हैं स्कूल में.
जय हो. Congratulations. Everybody understood?
Yeah.
Yes, sir.
Okay, so I'm giving a simple question. So what I will do, I will give you 3 questions. Okay, one more thing, just let me tell you. Sometimes while calculating in this meter bridge, there may be an error usually. There is an error. Say there is an error from the left hand side, means some extra length is supposed to be here, which we don't take into account, and some extra length from the right also, which we don't take into account. So just write down the heading errors. 90% question asked to you will be without errors, but in case it is asked, you can write down. What you have to do, error means it is always positive only. Means sometimes in 1 meter wire, there is some extra wire also on the left hand side and some extra wire on the right hand side, which we don't see with our eyes. So in that case, the actual equation, what it will be? R by X means this R by this X should be equal to X by this length. You can see from here actually that R by this length should be equal to X by 100 minus X. Correct, no?
हाँ
So R by, instead of that, you can write X plus something, you can write say alpha. हाँ alpha लिख लो तो अच्छा लगेगा. And here will be X by नहीं लिखेंगे, I mean 100 minus X plus beta. Means the little increment, this blue portion, let this be beta, and this blue portion, let this be alpha. Little bit extra length is there that needs to be taken into account. So using error, considering the error, this is going to be the equation. Considering errors, this is going to be the actual equation. Got it?
yes sir.
Everybody look at it for 5 seconds, like 10 seconds, and ask me if you have any doubts. Ask me if you have any doubts. I'll give you a question directly from DCP only. Everybody understood the question? I mean, these equations or not? Like I'll give one simple example from my end. See, आप लोग चुप्पी देख के हम डर जा रहे हैं. Say for example, this is 10 ohms and it is known to me. This R is unknown to me. This is meter bridge wire. What is the length of meter bridge wire? 1 meter.
1 meter.
Say for example, I take a galvanometer from here and I got a null deflection here at 20 centimeter. Find R. Everybody should be able to find R.
आ गया.
Everybody should get it. I'm telling you the options. Zara, you're getting?
Yeah.
What you got?
I'm just doing a few calculations.
Calculate fast. साक्षी हुआ?
हाँ सर मतलब हो रहा है।
देख मैं बताता हूँ
I'm
बेटा।
getting 40 ohm.
हाँ, see this is basically the principle is of what? Wheatstone bridge, right? In galvanometer, if no current is flowing, it means this by this should be equal to this by this. This is what a meter bridge is, right? So this means 10 by 20. Simply you have to do this 10 by 20. This 10 by 20 should be equal to R by 80. This 20 given, so this is 80. Yes or no?
Yeah.
So R is 40. So अरे समझ आया रे सबको?
Yes, sir.
हाँ सर।
Okay, next question, write down. Say for example, there is a resistance. There is another resistance. There is meter bridge. There is galvanometer. Quickly draw the figure. Okay. Again, you might get little random answer because I am taking the data random. This is 40 ohms. Unknown resistance R. So initially, I was getting the null point. Initial null point at initial null point at 40 centimeter. Okay, from left. It's from left. Yeah, always the scale is going to start from here only. So 100 centimeter. Okay, so we are initial null point is at 40 centimeter. Now find out. Wait, don't write this 40. Take this also as a known, say R1. Okay. Yeah. Take this as R1. Take this as R2. Initial null point was at 40 centimeter. Now R1 is shunted by 10 ohms. R1 is shunted by 10 ohms. So null point shifts by 10 centimeter. Find R1 and R2. If question is not clear, then you all can ask me. Initial null point R1 and R2 is connected. Initial null point we got at 40 centimeter. Now what we did, we shunted R1. Shunted R1 means shunting means we connect
पैरेलल में एक और 10 ohms ले लिए.
Yeah, in parallel we take a 10 ohm battery, like 10 ohm resistance. That's called shunting. So when we shunted, that null point shifts by 10 centimeter. Acha, in which direction null point will shift? It will shift here, or it will shift left hand side. See, if I'm shunting R1, then overall, when you connect something in parallel, then this gets reduced.
हाँ.
So the null point will shift towards left.
हाँ.
See, or if say for example there was a 4 ohm, if you shunt it now with another set something, say 2 ohm, so it will
हाँ.
get reduced overall. It's 8 by 6, that is now it's 4 by 3. Understood or not?
हाँ, पर अगर कुछ ज्यादा के साथ कर दिए तो?
एक बार देख ही लेता हूँ. Let us say we are shunting it with R. All right.
हाँ.
So now what is the equivalent?
4R by
4R by
4
4 plus R. And so that this is greater than, I mean sorry. अरे बाकी लोग को समझ में आ रहा है रे? Everybody is able to understand or not?
हाँ सर अंडरस्टूड।
लोग इतना दुखी लग रहा है, हम टेंशन में आ जा रहे हैं. I am saying that if
I
you
didn't
shunt,
get why it moved to the left.
that's what I'm explaining though. That's what I'm explaining. Okay. Say here it say there is a 4. Okay, let us go slow. So there is a 4 ohm resistance. Okay, Tara, 4 ohm resistance. What is the meaning of shunting? Is clear or not? You connect a
Yeah,
resistance
that's
parallel
clear.
to it. So now what is the equivalent? This much is the equivalent. Now this
Yeah.
equivalent to be less than the original one, what should be the criteria? What should be the this? So we can find the value of R from here so that this equality is valid, right? For the overall equivalent to be less than 4, this criteria should be valid, right? So if we
Yeah.
solve it, what we will get? R should be less than 4 plus R. What does this mean?
ये लेस होगा ही नहीं.
It means 4 is greater than 0, which is always true.
हाँ.
It means whatever you connect, it will always be greater only.
अच्छा.
नहीं समझ में आया?
हाँ.
अरे
हाँ समझ आया.
अरे this will always hold true, right?
हाँ.
Anybody has doubt 4 is greater than 0?
नहीं.
So it means basically if we solved it from here only, na, it means this equality will always hold true. It means anything you connect
हाँ.
parallel to this resistance, overall resistance will decrease than this one, original one. So in the question, it was said that R1 is shunted. An R1 is shunted by 10 ohm. It means I'm shunting this R1 now by 10 ohm. So the overall will be now less than R1. Okay. So if this is less than R1, so this will shift towards left hand side, right?
Yeah.
Sure.
Sure.
Yes, sir.
100% clear or not?
Yeah.
Okay. Solve. Now I've told everything. It's pretty simple now. We should be able to solve it. Solve fast. We have 2 minutes.
So for shunting, will that resistor will always be equivalent to 10 ohms only in parallel?
What? Repeat.
You said for shunting, we like attach another resistor in parallel, right?
Yes.
So will that always be equivalent to 10 ohms, or it can be any random?
I mean, it can be anything here. Shunted by 10 ohm means you can shunt it by anything.
But in this question specifically, we have given 10 ohms, right?
In
So
this
that's
question
why-
specifically, we are mentioning 10, so therefore we are taking 10 there.
Okay.
10 here. We have taken 20, 30, 40, 50. Shunting means connecting something in parallel. That's it. Oh, Krishna. So all of you do, I'll
हाँ
also do.
सर हो गया.
Congratulations. All you have to do is just solve. That's all. Got the answer? Okay, I'll also write the equations. See. First, R1 by R2 is what? For R1, what was the case? Null point was at 40. For R1, I'm writing 40. For R2, I'm writing 60. Clear this much?
Yes sir.
2 by 3. This is first one. Now, when I shunt it with a 10 ohm resistance, null point will shift towards left. We have just understood that. So now the new equation will be 10 R1 by 10 plus R1 by R2 should be equal to, so R1 by R2 have written, means this equivalent by this equivalent should be equal to this by this. So this one is what? 30 now. 30 by 70 means 3 by 7. These two equations are clear to everyone or not?
Yeah, it's clear.
Yes, sir.
Clear? Okay, now you see. R1 by R2 is 2 by 3. Let me put it here. So 10 by 10 plus R1 and R1 by R2 is 2 by 3. I'm substituting this R1 by R2 from above. That is equals to 3 by 7. Yes. So let's simplify this. 140 is equals to 90 plus 9 R1. Okay. From here I am getting R1 as 50 by 9 and R2 as 3 by 2 multiplied by R1. So 3 by 2, 75 by 9 ohms. Check the calculations once.
$50 by 9.
R1 50 by 9 नहीं आ रहा.
50 by 9. अच्छा R2 हाँ 75 by 9 हाँ.
Everybody got it or not?
हाँ सर
Yeah.
यही आया था.
आ गया सबका? Okay, so meter bridge is also
Yes, sir.
complete. Now you can refer to DCP, one example where the error has been taken into account. Error also, just put the values and you'll get the equation. You can refer to DCP. The solved examples. One error is given, and that's nothing new. Just put the values. All right. So now just just one more thing. I'll just tell you. Write down. Energy and power. Something was remaining. I'll solve 2-3 questions for you, and then we'll end this chapter here. Energy and power. See, we pay electricity bill, right? You might not pay. Your parents might be paying. Electricity bill. You pay electricity for what?
एनर्जी ये आप कहे थे.
मैं कहा कह दिया था.
हाँ.
For consuming energy. And what is the formula for energy?
I square RT या
I
V
square
square by
RT.
RT.
Yeah, V square by RT. All of you remember it, right? Power
Yeah.
multiplied by time is energy. Okay. So basically, energy means power multiplied by time. PT. Okay. Say for example, okay, before going ahead, I would also like to tell you for commercial purposes, please make a note of it. Commercial purpose means when you pay your electricity bill for your electricity expenditure in your house for commercial bills or purpose. How the bills are calculated, I will tell you. It is calculated like 1 unit consumption. What is the meaning of 1 unit? Say for example, I'm just telling you, price of 1 unit, say ₹7. I don't know what is the price of 1 unit in your locality. For state, for government electricity supply, it's less than 7. For private, it's more than 7 actually. So let's ₹7 per unit they charge. So we need to know what is this 1 unit. So 1 unit is basically 1 kilowatt hour. 1 unit is basically 1 kilowatt hour. So 1 kilowatt means 10 to the power 3 watts, and 1 hour means 3600 seconds. So that is 36 into 10 to the power 5 watt second, or 36 into 10 to the power 5 joule. That is 1 kilowatt hour, which is also known as 1 unit of electricity. 1 unit. Okay? Clear or not? So you don't pay bills as per watt, second or joules. You pay bill for kilowatt hours.
हाँ
I'm giving one simple question. Say there is a room in which there are 10 fans of 100 watt. ज़्यादा हो गया. 10 bulbs. All of you are alive, right?
हाँ
Yeah. हाँ
Rakhi
sir.
Rakhi is about to die. By her breath, I'm able to understand. She might leave her breath at any moment. So there is 10 bulbs of 40 watt each, and there is 5 fans operating at 100 watt each. There is 2 AC, say 3000 watt. कम बोल दिया भाई, 6000 का भारी भरकम AC. ठीक है, let's take 3000 watt. 3000 watt, maybe more than that also. 2 AC. ये सब काल्पनिक बातें हैं. घर में एसी वैसी रहता नहीं है, भिखारी हैं हम सब. तो 10 बल्ब 40 watt, 5 fans 100 watt and 2 AC 3000 watt. Okay. Now say for example, they are operating 8 hours per day. So every day they are operating for 8 hours. I'm telling you, one unit is, cost per unit is 6 rupees. Cheap rate. Find monthly electricity bill. Should I do it? Or try to
नहीं
do it?
करेंगे. बस एक चीज 10 बल्ब और 40 वाट्स मतलब एक एक का 40 वाट्स है.
एक वाट 40 वाट मैडम. 10 बल्ब मिला के 4 वाट, तो एक बल्ब 4 वाट, तो जुगनू हो गया, जुगनू. ग्लो होम. Okay, question is clear. 10 bulbs, each bulb has power of 40 watt, and they're operating at 40 watt also. Please make sure. Actually in your home, the series, there is no series connection. There's parallel connection. So every appliance gets 220 volt. So जो rating है उतना ही मिलेगा उसको, उतना ही power पे चलेगा. So every bulb is operating at 40 watt, 10 bulbs like that. Each bulb 40 watt, 5 fans, each fan operates at 100 watt, 2 AC, each AC operates at 3000 watts, and they are all operating for 8 hours in one day. Like that for 30 days they are operating. Find out the electricity bill for your home. Considering 1 unit to be 6 rupees. साराक्षी इसका आंसर देगी रे? वरना तो मैं हूं ही, टेंशन नहीं, मैं हेल्प करूंगा. Zara, you have your tuition from 6:30, right?
Yeah, 6:30.
You are calculating something?
Yeah.
किरे आज के हो गए?
हाँ हो गया.
কত বিজলি বিল?
331.2.
কি বলছিস? Yes.
हाँ.
Okay, see, 10 bulbs 40 watt each. So 10 bulbs will consume how many watts? 400 watt.
हाँ.
All of you are able to understand?
Yeah.
So total power 400 watt and each bulb for 8 hours. So 400 into 8 watt hour for the bulbs. Clear to everyone?
हाँ
Yeah.
For fans, how much? Total consumption of power 500 watt and 8 hours. So itna watt hour per day, 1 day I'm talking about. Plus
5,000 क्यों? 500 था ना?
हाँ भाई 500 500 and for ACs 6000 multiplied by 8 watt hour. Okay, this is for 1 day. Now what I need is kilowatt hour, right?
ओ 30 से भी मल्टीप्लाई, ओ मैंने तो एक दिन का बिल निकाला.
हाँ भाई तो मैं सोच रहा बड़ा सस्ता बिल निकाल. So for kilowatt hour I will divide by 1000, right? Then I will get 1 watt is 1 by 1000 kilowatt, right?
हाँ
Everybody is able to understand? Not able to
Yeah.
understand?
हाँ
Okay. It's not able to understand also, then no problem. Itna hero banega. Just remove this 1000. Just you calculate how many watt hours you got, tell me.
मैंने डायरेक्ट 1000 से डिवाइड किया.
चलेगा जो भी. तो अपना 3200, this is 3200 watt hour means 3.2 kilowatt hour. Agreed?
हाँ
Plus
Yeah.
4000 watt hour means 4 kilowatt hour.
4 हाँ
And this is 48,000.
हाँ
That means 48 kilowatt hour
हाँ
in 1 day. In 30 days,
30
this many
into
units.
30. हाँ
This many units are being consumed in 1 day. Got it, everyone?
हाँ
Yeah.
Multiplied by 30 to get your total units consumed in 30 days and multiply that by 6 to get your bill.
हाँ
So this is how much?
9936.
7.2. It's 55.2. Multiplied by 30 multiplied by 6, you will get the answer. 0 you remove from here, you will get, I guess, 6, 15, 1, 16 multiplied by 6. Quite expensive. 6, 6, 36, 3, 33, 3, 39, 3, 9936 आ रहा है क्या?
हाँ
Quite expensive.
इतना मेरे घर नहीं आता.
And that's because we don't operate ACs usually for 8 hours per day. This mainly
हाँ
is
हाँ
because of electricity consumption. This one, this color. Therefore, in summer season, if you use too many ACs, electricity also keeps on getting cut. Highest consumption is by AC. Okay, got this much, everyone? How to calculate the electricity bills?
हाँ
Yeah.
The basic understanding was 1 kilowatt hour is 36 into 10 to the power 5 joules. That is the unit of electricity. And just one last question I'll solve for heat and I'll end this chapter. So heat is basically I square RT, provided I is constant. Provided I is
constant.
What if I is variable? Then it will be I square R dt.
हाँ
Everybody understood?
Yeah.
So I am solving a question for you all. Let us say the current through a resistor is I naught sine omega t. Question is find heat produced in one complete cycle. One cycle means one time period. So time period of sine is 2 pi. I hope you all know the sine curve. Goes like this. So one time period means here it is 2 pi till this point. Okay, everyone?
हाँ
Clear now? Find
Yeah.
heat produced in one cycle. So heat produced is what? I square is I square R dt from 0 to time period. Now see, when time is 0, this portion is 0, right?
हाँ
Time period of sine wave means this portion should be 2 pi.
हाँ
See, from omega, see actually 0 to omega should go up to 2 pi. That is the meaning of completion of one full sine, right? Omega t is theta, na, angle. This should vary from 0 to 2 pi. Yes or no?
हाँ हाँ
Means omega t should vary from 0 to 2 pi. Yes?
हाँ
So from here you see time should be 0 to time should be 2 pi by omega. This should be the range of t. This is
हाँ
clear, Zara?
हाँ
Yeah.
Sarakshi? Tick. Okay. So now I naught square will go outside. Okay. Yeah, understood. Okay. So I naught square r and sine square omega t. Now, of course, I'm not going to integrate it. You further integrate it. It's like sine square theta is cos 2 1 minus cos 2 theta by 2. You have ever seen this formula? Sine square theta is
हाँ
sine
हाँ
square theta is 1 minus cos 2 theta by whole by 2
2 हाँ
Yeah.
and integrate it from 0 to 2 pi by omega. Now rest you can do on your own. I'm just telling
सर
you the
इसको बस चेन रूल लगा के भी तो कर सकते हैं ना
chain rule. तो इंटीग्रेशन में चेन रूल कहाँ से आ गया?
अच्छा नहीं सॉरी सॉरी
I naught square r by 2. This is integral of dt minus cos 2 omega t dt, whatever the limits be.
हाँ
I hope you all are able to understand.
हाँ
Yeah.
This is 2 pi by omega minus sine 2 omega t by 2 omega. अरे हाँ ना तो बोलो.
हाँ हाँ हाँ
Sine theta, right? So this much, yeah. And this should have the limit of 0 to 2 pi by omega. So I'm doing it here. I naught square r. This is important for your medical also. ऐसा नहीं कि स्टाइल मार रहा हूँ मैं. 2 pi by omega minus. So 1 by 2 omega anyhow goes outside. And inside, if you put t as 2 pi by omega, that is 0 and 0. So this whole will be 0. You can see on your own. You will get I naught square r pi by omega is the heat produced in one cycle. Okay.
हाँ हाँ हाँ
These kind of questions will come in alternating current again in class 12th only. Therefore, I gave just a gist here. I don't think it's a tough question. It's anyhow going to come in future chapter. This is called alternating current. I naught sine omega t. It's called alternating current. I once again repeat. This current is not fixed. It's called alternating current. We are going to see this. There is a heat produced for alternating current in one cycle.
हाँ
But the concept was I square RT only. That is what I wanted to convey. And if the current is constant, then simply I square R into T. It's clear to everyone?
हाँ सर आप आज का
Yeah.
ये पीडीएफ भेज सकते हैं क्या
हाँ, ये PDF I'll send in the group. Okay. Any other questions? Any other doubts? So
नहीं
now you all can solve the current electricity chapter. Objectives level 1. If you are too excited, you can go for level 2. No problem. HC Verma, you can solve full. In fact, last time I remember I had. Okay, sir. Actually, no doubts. Good. Last time when I used to teach. I mean, last time means when I used to teach in my young days. In that time, I used to discuss every question one by one from HCV. I would tell question number 1, boys would tell yes. Question number 2, yes, like that. Now my Josh has become thanda. I don't have so much of excitement. So you can solve, but yes, you all can ask doubts in very free way, no problem. Clear?
Yeah.
So you can solve anywhere, whatever you want to solve. But yes, not whatever you want. I have told you first, try to solve DCP objective 1. HC Verma, all the questions you can solve. And please, from next time onwards, next chapter, don't repeat this mistake that after the chapter gets over, you start solving questions from different books. This is a very wrong process. It should happen that whatever topics has been covered in that class, by the next class, this particular topic from all the books should be covered. If you're not doing that, you are creating mess for yourself. That should be followed. And it is your responsibility to clear all the doubts of those questions before the beginning of the next class. In this way, if you go, then it will be good for you. Otherwise, anyhow, I will teach,
Yes.
but आपको उतना समझ नहीं आएगा ठीक से. चलिए, आगे अब हरे कृष्णा
कृष्णा
कृष्णा कृष्णा हरे हरे
कृष्णा कृष्णा हरे
हरे राम
हरे राम
राम राम हरे हरे.
राम राम हरे हरे
Yes, Rakhi can drink some hot items and then go to bed.
नहीं आपका क्लास खत्म होने तक का ब्रीथ को रोक के रखी थी
अच्छा.
अब छोड़ दूंगी
Thank you.
Thank you, sir. Comments.